Hello and welcome back to the fourth video in the Learning to Program with SolderCore series. In this video I'm going to be looking at program loops. In the previous video you were given a brief demonstration of a for loop implemented by the for and next keywords. There are also three other types of loop: a for each loop, a repeat until loop and a while when loop. I'll start with the for loop. Okay, let's use the editor to write our program demonstrating for loops. Edit. Okay, so to create a for loop, do so like this: for, then a variable name, and the starting value of the variable and the ending value of the variable. We also need a next I. So what this sets up is a loop that's going to execute 14 times. Each time the loop is executed, I is incremented by 1 each time. So the first time it runs, I equals 0. The second time it runs, I equals 1. I'll just quickly show you print I. If I run that, you can see there the value 0 to 13 is printed out. Okay, let's do something a little bit more interesting. Let's use this loop to switch on the pins of the SolderCore. I've currently got it set up so the SolderCore is connected to a breakout board, which you can see in the bottom right hand side. So core D I equals 1. Okay, and I'll have another loop for I equals 0. Oh no, for I equals 13 to 0, step minus 1. So I want this second loop to count down from 13 to 0. And in this loop, again I want to control digital I/O. This time I want to turn it off. I'll just add a little bit of a delay. 0.01 0.01. Okay, right, if I run this now, you should see in the bottom right hand side the LEDs sort of strobe back and forth. Okay, which it did, which is great. So that's so what it's doing is iterating this loop 14 times, so switching on all the LEDs one at a time, and then in the second loop it's starting at pin 13 and it's decrementing by 1 each time and switching off the pins. This is done so by the core.di equals 0. We can now wrap these two for loops within an outer for loop. 0, 2, 4. Next. Like so. If we run this program, what you should see is it executes 5 times. 1, 2, 3, 4, 5. Like so. So easy peasy. Okay, the next program is going to demonstrate how to use the for each loop. So let's create a new program, type in new, select the editor, which now should be blank. Okay, so to iterate through an array, we use the for each loop. But so to do so, we're first going to need an array. So let's create one. My array equals, and then we're going to use a new word you haven't seen, expand. This is going to convert a string to an array of ASCII values. So core basic is really easy to use. Okay, that's my array, and now we're going to iterate through my array. We're going to use the for each loop, for each, and then a variable name. Let's call it char. Let's call it my char. In my array, like so, and then we need a next statement at the end of the loop next to my char. Okay, so if I do print, let's convert the ASCII values back into characters using the CHR keyword. My char. Okay, I'll just quickly run that so you can see what it's doing. So it should print out each of the characters to the screen, which it does there. So core basic is really easy to use. Oops. Okay, let's make this more interesting now. Let's start playing with the hardware. Let's install the parallel bus driver. Install parallel bus. And I'm going to use 8 pins. This is going to be a bit slow. So using core.d0, core.d1, 3 dot D5 6 core dot D7. Okay, and as my bus, and my bus now consists of pins D0 to D7 on the SolderCore. Okay, so what I really want to do is I want to display using LEDs this sentence. So I'm going to do that using my bus, and I'm going to output and the characters. And I'm going to pause so you can see this happening, otherwise it'll be too quick. Pause 0.05. Okay, I'll just quickly walk through this before we run it. So I'm installing the parallel bus driver, and we access that driver using the MyBus variable. The parallel bus driver consists of pins D0 to D7, and we're going to use the output method in this demonstration. Then I create an array. The array consists of the characters in this string. We do that using the expand keyword. And then what we're going to do now is for each character in the array, we're going to implement these statements. So first of all, we're going to print the character. Then we're going to output the character to the bus, which is a mistake there. Then we're going to delay for 50 milliseconds, and then we're going to do it again until we run out of elements in the array. So I'm just going to have the clear screen, and if I run that now, what you should see on the hardware, on the breakout board, is the first 8 pins flashing away. Let's try it. Let's hit F5. There you go. So you can see them flashing away, writing out those sentences, that sentence using LEDs. Okay, so that's how you use for each loops. Okay, the other two loops, the repeat until and the while when, are both very similar. So let's just create. In fact, what I'm going to do is I'm going to load the previous example. Just list that to make sure it's okay. Okay, so this one is the one that just strobed the LEDs backwards and forwards. So when this one ran last time, it executed 5 times, and that was set up by this for loop, this for j equals 0 to 4. Perhaps you want to run it indefinitely until an action occurs. So this is when you may use the repeat or the while loops. So we'll use the repeat loop first. So let's just delete the for j loop. Okay, I'm going to use the repeat keyword. That's at the top there. And until what I'm going to do is I'm going to monitor pin 14. So it's basically going to run this program until pin 14 is low. What I need to do now is tell SolderCore that pin 14 is a digital input. That's it, that's all you need to do. Okay, if I zoom out a little bit on the camera. So pin 14 is this one down here. It's currently high, so when I execute this program, it will just continue doing so. And it will do that indefinitely until I set pin 14 low. So if I now plug this in, it's gone low, and it will stop execution like so. So the statements within a repeat loop always get executed at least once, as the loop evaluation is done right at the bottom here. The other type of loop, a while loop, the evaluation is done at the top. Let me show you. So instead of repeat, we'll have a while, and then pin 14 equals 0. Do the stuff we don't need the until anymore. We can delete that. Okay, so this loop will only execute if pin 14 is low. If pin 14 is high, this loop never gets executed. So there is a difference between the repeat and the while loops. So in this video, we've looked at the 4 types of loops that you can use within Core Basic. In the next video, we're going to look at procedures or functions, and we're also going to look at the digital I/O in more detail. We have seen it briefly already with these core.di statements, but we're going to look at also analog outputs, analog inputs, digital inputs, digital outputs, and also the bus command. Thanks for watching.